that we coordinated in collaboration with the Department of Environment, Land, Water and Planning. My name is Jess Coxon and this is Madi O'Brien. And just before we get started, we'd like to acknowledge the traditional owners of the land on which we meet and present to you today. We pay our respects to elders past, present and emerging.
So, Jess and I are both third year marine biology students studying at Deakin University here in Warrnambool. I guess what led us both here was the course itself. We both have a strong passion for protecting and conserving the environment, in particularly the marine environment. And we want to make a difference, even if that contribution is a small thing, to ensure our oceans can be enjoyed for future generations to come. And we're also the volunteer coordinators for the 2018 Warrnambool Whale Watchers program.
So just a bit of history about the program and how we got it running. So back in our first year in 2016, the program was actually run by another Deakin student. And then in 2017, no one took that over from her position. And that just so happened to be one of the best seasons Warrnambool has ever seen with the whales. And then so this year, we were hoping it was going to be up and running again. And we were sort of waiting around to see if we could sign up to be a volunteer. But again, no one was running it. So we thought we'd put our heads together and get it up and running again. So we did this by contacting Mandy Watson. She's the Senior Natural Environment Programs Officer here at DELWP Warrnambool, and she was also our Senior Project Officer for the monitoring program. She has been a part of southern right whale research since 2002. She leads the Cetacean Emergency Response Training Program and is the first point of call when there is a marine mammal entanglement locally. So the whale monitoring program used to be solely run by DELWP employees themselves, which proved to be tedious. And so since 2007, they introduced citizen science. And back in those days, any member of the community could be a part of the program. However, today it is usually run by Deakin University students, such as ourselves. So DELWP are mainly responsible for the monitoring program. However, as southern right whales are of international significance, funding does also come from the Commonwealth.
As volunteer coordinators, we had quite a number of responsibilities. This included creating flyers, as you can see up there, to advertise the program around campus. We were also in charge of recruiting volunteers, holding inductions to train our volunteers on how to monitor and record data, also teaching about public awareness, as we're not only representing DELWP but Deakin as well, and most importantly OH&S in accordance with DELWP's volunteer protocols and procedures. We also had to develop rosters and delegate shifts and constantly liaise with our volunteers and DELWP throughout the season. We also had to collate all of the data collected by our volunteers into a spreadsheet, which then went back to DELWP.
So for those of you not familiar with the southern right whale, they are a long-lived species. They can reach up to 80 years of age. They reach a maximum length of around 17.5 metres and a whopping 80 tonnes they can weigh up to. They are slow swimming and have a thick layer of blubber, and the females are slightly larger than the males. Females reach sexual maturity at around 5 to 6 years of age, and they usually reproduce around every 3 years. The females display strong site fidelity, meaning they return to the same site to calve, and it is their slow reproduction rate that has resulted in only a gradual recovery from whaling.
So southern right whales are baleen whales, which they feed by skimming the surface of the water with their mouth open or by shallow dives with their mouth open. And then when they close their mouth, they use their tongue to push the water out and trap their food in the baleen fibres. Their diet consists of zooplankton and krill, which are small crustaceans. Adult southern right whales are generally not preyed upon. However, calves, juveniles and weakened adults can be killed by sharks, in particular the great white, and also killer whales.
So southern right whales inhabit temperate waters in the southern hemisphere. During summer, they feed in the nutrient-rich subantarctic waters, and then during winter, they move to the warmer waters of the southern coast of Australia, South Africa, South America, and New Zealand. And this is where they mate and calve. As you can see in the diagram, we have a number of aggregation sites along Australia's southern coastline. The southwest population is recovering at the maximum biological rate. However, there does not seem to be an increase in the southeast population, and this is also evident in the diagram in our little part of the world. So the bigger the triangle, the bigger the aggregation population size is.
So prior to the whaling industry boom, the estimated historic population size was 55 to 70,000 individuals in the southern hemisphere in the 1700s. And then the southern right whale was nearly hunted to extinction in the 1800s due to commercial whaling. The species was so popular to hunt because they're slow moving, they like to rest on the surface of the water, and they contain large amounts of blubber, which yields a lot of oil, which is then used in margarine spreads, in soaps, in cosmetics, and for oil lamps. And this is why they're named the right whale, as they are the right whale to hunt. As a result, by 1920, numbers were fewer than 300 individuals. Whaling was then outlawed in 1935, and this has allowed their numbers to increase. However, the current abundance is still well below the historic population size, and they remain endangered and are listed as so under the Commonwealth Environment Protection and Biodiversity Act. Victorian legislation lists them as critically endangered under the Flora and Fauna Guarantee Act, and provisions are put in place under the Wildlife Act to protect southern right whales occupying the Logan's Beach Whale Nursery by an exclusion zone during whale season. And we'll be going over the exclusion zone in more detail later in the presentation.
So we'll just go through how we actually monitored and collected the data this year. So we had a total of 27 volunteers, including ourselves, that participated in this year's program. Our volunteers were broken up into small groups, around 2 to 4 people, to attend 2-hour shifts from 12 to 2 p.m, 7 days a week. Each group was given a clipboard that had our monitoring data sheets, a pair of binoculars, and a display folder that had important documentation, including OH&S documentation, the Beaufort Sea State, and other stuff. Data entries were done every 20 minutes, as the whales can hold their breath up for 20 minutes. And so once a group starts their shift, you would usually get to the platform and scan the water with the naked eye, and it is then once a whale is spotted that you would use your binoculars to identify the species with its body features and observe its behaviour. And then one member of the group will be recording the data throughout the shift.
So this is the data sheet that we use throughout the season. As Jess said, data was entered every 20 minutes. Some of it's quite self-explanatory. You've got the date, the weather, the visibility when looking out to sea. You've got the sea state, which is using the Beaufort wind scale, which is this one here. Number of whales and specifying if that's an adult or a calf. The species of the whale and the direction when looking out from the viewing platform with using an imaginary clock. So you've got, from looking out, you've got 12 o'clock, 1, 2 and 3, and then 9, 10, 11. We've also got the distance in metres and their behaviour, specifying if they're travelling and if so in what direction, if they're resting, etc.
So how do we actually identify a southern right whale? So they can be easily distinguished from other whale species as they do not have a dorsal fin. They have large, broad, rectangular pectoral fins and a large head with a strongly arched mouth line and big white patches of keratinized tissue called callosities. Now these callosities provide habitat to 3 amphipod crustaceans, commonly known as whale lice, that feed on the whale's skin. And callosity patterns are as unique as a human fingerprint and can be used to identify individual whales. Baleen whales also have 2 nostrils as their blowhole, which creates a V-shaped blow. However, this V shape can only be seen when the whale is facing the horizon or the shoreline, as you can see in this picture here. This cannot be seen when the whale is in side view, and therefore all these characteristics should be used in conjunction for correct identification.
So where does the data go? Well, the data from the Whale Watchers program is then added to the DELWP Southern Right Whale Sightings database. This database also contains incidental sightings from across Victoria and is collated annually by Mandy Watson. All of these records in the DELWP database are then added to the Victorian Biodiversity Atlas, or the VBA. And then the data is used by DELWP to provide advice to developers and other agencies, such as the Commonwealth Environment Department and the National Offshore Petroleum Safety and Environmental Management Authority. And this is regarding marine oil and gas exploration proposals and other coastal developments. The data is also used for research purposes, such as investigation into the southern right whale population size, structure and recovery, as well as conservation management. So why is this important? Well, Logan's Beach Whale Nursery is one of the few in the world, and it's imperative that we protect it and have a clear understanding of the species to ensure its recovery.
So there are many threats to the southern right whale, including entanglements in fishing line, ropes and nets. This picture on the right is actually from this season of a southern right whale that was entangled back in August off the coast of Portland. The southern right whale are the primary species that is involved in vessel collisions, and the presence of vessels can affect their normal behaviour. Today, the threat of whaling is due to illegal whaling. However, the potential for other countries to recommence commercial whaling exists, and pressure may well increase as the population size increases. There is evidence that climate variability affects reproductive output in the southern right whale, and significant changes to climate can lead to decreased prey distribution and availability. Noise interference from drilling, exploration, mining, dredging, infrastructure construction and defence activities may cause interruption to communication between individual whales, disrupt migratory movements and cause physical damage to the whale. Habitat modification due to the development of infrastructure such as ports, marinas and aquaculture facilities can cause physical displacement of individuals. Furthermore, chronic chemical pollution such as agricultural runoff and sewage outfalls, as well as acute chemical discharge such as an oil spill, may cause habitat modification. So we don't want any oil rigs in the bight. And finally, krill and copepods are the primary food source for southern right whales, and the overharvesting of these species is a potential threat.
So what can we do to help the southern right whales? Well, firstly, keep your distance. Listed up here is the distances by law that you must keep between you and a whale at all times when operating those vessels. Here is what the exclusion zone looks like. So it is approximately 1 kilometre offshore from Point Ritchie, 4 kilometres across to Gould's Cave. Here's the number that you can call if you see a vessel within the exclusion zone from the 1st of June to the 31st of October. And we've also put up the whale and dolphin emergency hotline for entanglements and strainings. And finally, just put it in the bin.
So firstly, we'd like to thank Mandy Watson and Louise Falls from DELWP. They've been an absolute pleasure to work with, and we are really grateful for Mandy for giving us this opportunity to coordinate such an amazing program that was not only beneficial to our volunteers but to ourselves. And thank you to all our volunteers that we have listed here. It would not have been possible without you guys. We needed at least 14 of you to get the program up and running, and we had 27 in total. And to our other volunteer coordinator, Bree, who could not be here today. And then finally, Jules Mondon, Ty Matthews and Alicia Belgrove for their guidance and help with the initial launch of the program and for getting the word out to Deakin University students.
Thank you for listening.
Questions?
Yes?
Any interesting observations from the data this year, or just their general behaviour or parts of the coast around the nursery that they occupy more than others? Or
This year, oddlips and her calf like to be down in the southeast corner, sorry. We don't know why, but sometimes she likes to hang down there. Whereas last year, a lot of them like to hang around in that Hopkins Reef. That's not far from the mouth, yeah.
Yeah, so from the platform, you couldn't really see much a lot of the time. She's over that way.
So was the river mouth open a lot last year? It
Not
might
too
actually
sure.
align with what Jules was saying earlier around
Yeah,
the freshwater discharge.
yeah, I'm not too sure if it was or not.
It
was.
Was it? Okay. And this year, was the mouth open?
I think so, yeah. There's a lot of dirty water out. Sometimes we were monitoring.
Okay.
Yeah.
Were they surfing at all this year? Did you see them coming in
No,
with a surf?
no, not
Really.
surfing.
Sometimes like porpoising and like spy hopping, but
Yeah,
they're
yeah.
not surfing.
Breaching, mother likes to roll around on her back and you can see the calves trying to get up on her tummy and
Yeah,
just playing.
Just playing a lot,
Mm.
which was really cool to watch.
Any explanation for just the low densities this year?
They think it was just not their 3-year, didn't land right on that 3-year when they usually calve. So last year that could have hit that real 3-year when a lot of them were ready to give birth. So maybe in a few years' time we might see another room, I guess.
Yeah.
And how quickly did that little one appear to grow? And when you first saw it, roughly how big would it have been compared to when it left? Use car sizes as an example.
Volkswagen RAV4, no. Touchy subject. I couldn't really notice a difference in size, if I'm honest.
Well, from our data, you could see for the first few weeks we were only recording one whale because we wouldn't have been able to see the calf with her, because obviously when they're so young they're very weak and just on the surface you can't see them, but then towards the end we could always make out that the calf was there, and yeah, definitely a significant change in, I guess, growth and strength of the calf.
And did the mum over time appear to get skinnier? If you look at the backbone.
On the bump, yeah.
Yeah, I wonder.
Didn't take notice of that.
Yeah, okay.
How large are their babies?
I think they're like 5 meters. or
Yeah,
something.
yeah.
5, 6
Yeah?
meters, yeah.
At birth?
Yeah, I think so.
Wow.
Confident.
Brings a tear to the eye, doesn't it? So what about around Portland and Port Fairy this year? Are the numbers up over there?
Yeah,
Yeah, but yeah.
they sort of had a lot more sightings than we did.
Come have a look at our props if you want.